So please, I welcome Kirsty Gogan, who is co-founder and global director of Energy for Humanity organization, that is an environmental NGO focused on large-scale decarbonization and energy. Please welcome.
Thanks so much. Good morning, everyone. So thanks, Tony, for your, warming up some of the issues that I'm going to be speaking about today. I'm going to focus on cost reduction. But before I sort of open, I would like to just make a remark about the comment that Dr. Fatih Birol made in his opening remarks to the conference yesterday, when he talked about the gap between ambition and reality, the gap between government ambition and the meetings and the targets that are being set and what's actually happening in the real world. Because despite 30 years of successfully raising the alarm for action on climate change, we haven't made a dent in the upward trajectory of emissions. And all of the most credible, authoritative studies tell us that we need a massive expansion of solar and a massive expansion of wind and energy efficiency and carbon capture and storage and nuclear energy. And yet, what we see is a very significant gap in what's happening in the real world in really advancing the deployment of those low-carbon technologies that are seen as being necessary for us to achieve our carbon reduction targets within those meaningful timescales. Half of the emissions that are currently in the atmosphere today have been emitted in the last 30 years, and we have another 30 years to turn the tanker. And so we really ought to be pushing for all of those technologies that are seen as necessary. However, some argue that we can't rely on nuclear technology to make a meaningful contribution towards solving climate change because it's too expensive and slow. And if we look at recent experience in Europe and in the United States, nuclear does look expensive and slow. And so I'll be sharing with you some of the findings of a study that we were commissioned to deliver, looking at what drives those costs, what makes nuclear expensive and slow. So here are some of the studies that we'll be looking at today, which hopefully you'll have access to these slides, and some that aren't mentioned here are the MIT Future of Nuclear Study, the OECD, the excellent OECD report that Tony mentioned from the year 2000, and it's my great pleasure to be on a panel today with Jessica, whose work was really fundamental to our study as well. So, what do nuclear plants cost? Well, as I said, it's widely believed that nuclear is very expensive, but actually nuclear plants are being delivered around the world today at 50 to 80% lower capital cost than current and recent projects in the United States and Europe. And you can see the range of costs here represented in just a small sample of the 30 plants that we looked at in our study, that were all either recently completed or close to being complete around the world. Now, at the level that we see on the right-hand side of the chart, achieved by China, Korea, Japan, these plants are actually competitive not only with other low-carbon forms of energy, but also even with fossil fuels. So what drives these cost outcomes? Is it because labor is cheap in China or because corners are being cut on safety? Well, our study set out to really understand what drives the cost of nuclear and to establish what, if any, best practices could be transferred to the UK or to the US context. Now, Tony's really helpfully introduced the concept here of the benchmark plant, which, as he said, was based on the EEDB database of tens of plants that were built in the United States with very detailed cost data. And you can see here that we've given a breakdown of what the sort of high-level costs are, including interest during construction, which for the purposes of our study we set at 7%. Across all the plants that we reviewed, and we brought all of the plants up to $2017. But we also have owner's costs, and you can see that big blue piece there is indirect services costs, which are things like, for example, interaction with the regulator, and those sorts of design engineering, those sorts of costs. And then we have labor, we have equipment and materials, and then a small amount of pre-construction costs. Now, it's worth saying that we didn't include pre-development costs in our study. So, for example, in the UK, the cost of licensing and gaining planning permission to build on a site, those kinds of costs weren't included in our study. We just looked at construction costs, but we did include interest during construction. And actually, it's worth just saying that including interest during construction, even at a levelized cost of 7% across all the plants, is very significant as a driver of cost. And the reason for that is because it depends on how much you borrow and for how long. So your schedule duration and your overall budget will make a very significant difference to your overall cost of financing. So there's two key insights on this slide now that I'm going to show you. Firstly, first-of-a-kind costs. Now, we've already heard a little bit from Tony about the importance of this. Building something for the first time or doing it in a country for the first time, and for example, after a very prolonged pause, so we would call that like a first-in-a-generation plant, will make it very difficult to implement best practices and achieve high labour productivity. And those are two of the key drivers in the study and throughout the project. So what you're doing essentially is restarting your industry, and we're seeing that happening today in the United Kingdom, in France, in the United States, in Finland. All of those high-cost plants essentially are first-of-a-kind plants, and as a result we see long construction schedules, we see very high indirect services costs associated with engaging with the regulator and building up the capability and the capacity within the supply chain, achieving the qualifications that are needed, the substantiation of the designs. All of that represents a very large investment, especially when you're doing it for the first time. So you can see here the benchmark plant in the middle, which is about the median for the rest of the world, for the world, and then you see the rest of the world plants, and you can see there that actually, interestingly, the equipment and materials, which are the red and the sort of sky blue boxes there, remain broadly consistent across all of the plants. But really the big differentiator is in the interest during construction and the indirect services costs, if you look at the most expensive and the cheapest. So essentially, if you're building an AP1000 in China or an AP1000 in the United States, the cost of equipment and materials will remain broadly the same. What will really differ is your construction schedule and your indirect services costs. And remember, of course, that we levelized the interest during construction, so that wasn't the feature here. And then even more so, what we see here is the US best experience. Now, from the EEDB database, we took the median experience. But actually, when we went back in to interrogate the data further, what we found was that actually even the United States was achieving very low cost construction during the height of its new build program. And the significance of this is that that actually achieving very low costs isn't country specific. It's not, I've already described how it's not technology specific. You can build an AP1000 in China and the United States and achieve very different outcomes. But actually it's not culturally specific. The truth is that you can get really good at it in terms of project management, continuity, standardization, having a successful interaction with the safety regulator. And interestingly, a successful interaction with the safety regulator isn't, something that we should be afraid of. It's actually something that's to do with having good experience, good judgment, a familiarity with the design, an understanding of the safety case, and all of those result in a more efficient licensing process. Investment and buy and depth of the supply chain is absolutely critical. The cost really for the supply chain and for the developer investing in the supply chain's capability and costs to substantiate designs and to substantiate the safety case of delivering equipment and components is very substantial. Once that investment has been made, if you continue to produce those equipment and materials, then actually you can achieve very efficient cost outcomes. And then, of course, experienced project delivery organizations, then you see an overall increase and benefit of productivity, even in the United States. So I've described how we can make nuclear cheap through investment in best practices in project management and construction execution. Well, we can also make it really expensive. Now, I don't want to dwell too much on these slides because I think Jessica will go into more detail in her presentation here. But we would show some of the data that Jessica's produced, where we see very low-cost plants being delivered in the United States and in France. And then two things happened, 3 Mile Island and Chernobyl. And we can see that after those events, those plants that were under construction at the time of those accidents and then underwent very significant regulatory reviews, very substantial design changes, midway through construction, ended up with a very significant cost increase. And then what we see is a big gap. We see decades worth of gap. And then we see, again, those very high costs as a result of having lost all of that experience and construction experience and construction expertise, and having to go back and relicense new designs again. So honestly, the best thing that Vogtle could do next. So Vogtle is the plant in the United States that's been quite problematic, experiencing very significant delays and cost overruns. But what we're hearing anecdotally is that actually Unit 4 is coming in substantially cheaper than Unit 3, because Unit 3 has really carried the burden of all of those additional costs of setting up the industry, of licensing, of establishing the capability within the supply chain. We haven't had the opportunity to look into this in detail. A study really is needed. Sorry, I just jumped ahead there. So this plant, again, from Jessica's data, shows how we've actually lowered the cost of nuclear in the past. And you can see here from South Korea and China over the course of their program how they've achieved significant cost reductions from Daya Bay being the first of the Chinese new builds, and then achieving very substantial cost reductions after that by standardizing the design, by investing in the supply chain, by starting construction with a complete design and building continuously. Starting construction with a complete design, by the way, if there's one single takeaway from this study, is that is one of the biggest determinants of a low-cost outcome. All of the high-cost plants that we reviewed started construction with a very low percentage of design completion. And the result of that rippled out into further regulatory investigation during construction, changes on site, delays in developing codes and standards for the supply chain, and ultimately resulting in budget overruns and schedule delays. So, first-of-a-kind plants are expensive. The best thing that we could do, once we've invested in a high-cost, first-of-a-kind, first-in-a-generation plant, is to build another one. We have to see these first-of-a-kind plants as an investment, and that if we do not sequence the subsequent builds, we will lose the capability and the experience that's been gained, the licensing that's been gained, and the longer the gap, the more expensive the next one will be. And that's really the case that we're making in the UK to the UK government with the build of Hinkley Point C, which, by anyone's standard has been an expensive plant, but we ought to see a very substantial cost reduction for the next plant. And here's a case study that illustrates this, which is from Sizewell B, which was the last nuclear plant that we built in the 90s in the United Kingdom. So our ETI study showed the breakdown of costs that we had from very detailed cost records from the build of Sizewell B up to the blue bar. And then we've since actually added the first-of-a-kind costs that would have also been invested in that plant associated with site acquisition and consents and permitting, the reactor design costs, the cost of licensing, and the additional costs of interest during construction that would have been associated with that. So you can see that we now have really quite a significantly expensive first-of-a-kind plant, quite a good representative first-of-a-kind plant cost as a result of that for Sizewell B. But at the time that they were building it, they were taking very detailed quotes from the supply chain against the plan that they had to build another unit, an identical unit on the same site. So we have contractually binding quotes for the next plant. And you can see that because they were intending to replicate the design, using the experienced supply chain, having invested in all of the design qualification, and the construction experience having been established within the labour force, we can see that the cost estimates for the subsequent unit were coming in substantially cheaper than that first unit. Now, that unit unfortunately wasn't built, but it should be a lesson to all of those governments looking at their high first-of-a-kind costs in their countries and deciding whether or not to really maximise that investment by building more plants. Here's another example of a multi-unit program. Sometimes when we talk about a fleet effect, we think that requires, a sort of 10 gigawatt scale commitment from governments, but actually we see a fleet effect even between 1 or 2 units on a single site, or even in the case of Barakah, even better, between 1 and 4 units, when then you can really start to drive down cost, not only because you're stripping out those first-of-a-kind costs, but you're also starting to really gain and cut into the productivity gains and those learning effects within the supply chain and the labour force. So we know that well-organised programmes can reliably deliver low-cost plants. But before I finish, I would just like to highlight 2 additional approaches to cost reduction. So the first of 3, we've heard about improving delivery via a programmatic approach. We can drive costs down to very competitive levels, even with gigawatt scale, conventionally built, stick-built construction of large light water reactors. And we can do that through continuous building, being disciplined in capturing and disseminating learning, developing a deep competitive supply chain, building as many units per site as possible. In China and Korea, we're seeing 4 to 6 units being built on sites, which is one of the significant drivers of the very low costs that are being achieved in those countries. And then, of course, standardized design and really taking a long-term view. Beyond that, there's other things that we can do to reduce costs on site, such as, for example, seismic isolation. One of the things that we see, particularly in the UK, for example, is site-specific design. So even when you're intending to replicate your design as much as possible, when you move to a new site, you inevitably need to reopen some of the design case, some of the safety case, which does require additional design engineering, additional interaction with the regulator. Some of those additional costs could be designed out and standardized to avoid site-specific design. We could be redesigning for low-cost delivery for next-generation plants. We're seeing that now in the SMR program. And the SMR plants not only are designing to be factory-built, to be moving from being projects to products, but they're actually designing for low cost. This is an example of the GEH BWR X300, which is using as far as possible off-the-shelf components that are very well known, very well demonstrated, and present very little risk in terms of regulatory and licensing, driving out cost and driving shorter construction schedules. We can see this in other sectors that we should be learning from, including, for example, shipyards, which are very productive manufacturing centres. So rather than making these reactors in field, 5,000 guys in a muddy field, why wouldn't we be moving into high manufacturing areas like shipyards that build highly regulated and complex and very large machines? So we see potential for very substantial cost reduction through shipyard manufacturing, stripping out costs even further than are intended or, well understood at the moment within the SMR space. And in conclusion, I would say that the largest sort of volume of plants that are being delivered in the world today are actually low cost. There's a very significant gap in the narrative around the cost of nuclear, which is really confined to the context of a small number of first-of-a-kind, first-in-a-generation plants being built in the United States and Europe. So we need to broaden our horizons and learn from the success that we're seeing in other parts of the world and understanding how many of those best practices are transferable into the United States and the UK. These are very well characterized pathways to lower and potentially very low costs. And I guess I would leave you with the question that with which I sort of started, which is, what would we do differently if we decided to support nuclear with the full range of options that we already use to support renewables? Renewables didn't start out cheap. They got cheap through a very coordinated and coherent effort by industry, by government, by investors, to really identify what it was that was driving costs, and then working hard to strip out those cost drivers and deliver, the successful low-cost deployment that we're seeing today, and ultimately achieving investor confidence, achieving government's confidence. We can and we should be doing the same thing for nuclear. And then finally, how would we change what we do on a daily basis if we actually believed that the widespread deployment of nuclear energy was necessary for the survival of our children and our grandchildren? I said at the beginning that we have 30 years to turn the tanker. Well, in the year 2050, which is the big milestone that we're all focused on here, my daughter will be the age that I am now. And that, to me, doesn't seem like that far away. So we have the tools, we have proven strategies, we have evidence that it's achievable, and I would urge you, in all of your capacities, to please get on with it. Thank you.